Okay, here are the 2.1 notes, additional information on completing the square. So we are going to continue on where we wrapped up the 2.1 notes, and that is with the standard equation of a circle. Standard equation of a circle with a center HK and a radius R looks like this: x minus h quantity squared plus y minus k quantity squared equals r squared. And we like it in that form because it makes it really easy for us to identify the center. Here it's 7, negative 2. Sorry, our equation is x minus 7 quantity squared plus y plus 2 quantity squared equals 25. And then our radius is that square root of 25, so our radius is 5. Sometimes, though, we want it in general form. Typically, standard form gives us more useful information, but sometimes you may see it in general form. So let's talk about the differences. General form pretty much just has everything multiplied out. I don't have any sort of binomial being raised to a power. So example 9, we want to write the equation x minus 7 quantity squared plus y plus 2 quantity squared equals 25 in general form. We are going to start by expanding both of those squares. We're going to multiply x minus 7 times x minus 7 and y plus 2 times y plus 2. I'm going to go ahead and leave the 25 over here for the time being. We got x squared minus 14x plus 49 plus y squared plus 4y plus 4, and then I'm going to go ahead and subtract the 25 so everything is on the same side. Now I am going to write it in descending order. X squared first, then y squared, then my linear x term, then my linear y term, and then my constant. So there is that equation in general form. Okay. Very rarely are you going to be asked to do that. Chances are you're going to be asked to go the other way. Take something from general form and write it in standard form, because guess what? If it's in standard form, that gives us more information as far as graphing it and as far as the points we're interested in. So example 10, we want to take the general form of x squared plus y squared minus 16x plus 14y plus 32 equals 0. We want to write that in standard form. So if you are not familiar with this would be a great time to pause the recording, take a look at example 7, walk through the steps there. I am not going to take time here to read that to you, but I'll meet you on the other side. And we'll start with example 12. So we are going to solve this equation by completing the square. It looks a little different than what we're doing with the circles. It's also just got one variable to deal with. So I'm going to start by just rewriting this with a little room. And then I cut my linear coefficient in half. I'm going to cut this 6 right here in half. I get 3. I'm going to square that. That tells me what I'm adding to both sides. So I'm adding 9 to both sides. This side, and you definitely don't need to write out this step, but you can. Factors into b plus 3 times b plus 3. This is b plus 3 quantity squared equals 12. If we want to solve that for b, we are going to square root both sides. And I get b plus 3 equals plus or minus square root of 12. We're going to simplify that in a minute. Subtract the 3. I get negative 3 plus or minus the square root of 12. 12 can be written as 4 times 3. So I end up with negative 3 plus or minus 2 times the square root of 3. So we've solved, we found b. We started with a quadratic. We ended up with two separate solutions. All good. So now let's go back to example 10. We want the standard form of the equation for this circle. And so I'm going to start by rewriting this and grouping my x's together, my x terms, grouping my y terms together, and moving that 32 to the other side. There are some times that you will see the 32 left on this side, and then we add and subtract to the same side. I like moving it over, especially for the equation of a circle. So negative 16x, I'm going to cut that in half. I get negative 8. I square that, I get 64. So I'm adding 64 to both sides. Y squared plus 14y, cut the 14 in half, we get 7. We square that, we're adding 49. X minus 8, quantity squared, plus y plus 7, quantity squared we get equals 81. Notice that's a 1. This is not asking us for the center and the radius. This is all we need to do. But from this form, it's pretty easy to pull out the center and the radius. Example 13 is in here because this one looks just a little different. Notice that now we have a coefficient in front of that x squared, and we need to deal with that before we complete the square. So I'm going to go ahead and move the 3 to the other side. And then I'm going to factor a 2 out of everything on the left-hand side. Doesn't affect what I have on the right-hand side at all. Now I'm going to complete the square inside the parentheses. So negative 4x, I'm going to cut that coefficient in half. I get negative 2. I square that, I add 4. But look at what we have over here on that left-hand side. This is really 2x squared minus 8x. It's what we have from above, plus 8. So by adding that 4 inside the parentheses, I've really added an 8, which means I need to add an 8 on that right-hand side as well. Now I've got 2 times x minus 2, quantity squared, equals 5. This just asked us to complete the square. It didn't really ask us to solve. But we could continue on and solve this. I get x minus 2, quantity squared equals 5/2. Square root both sides, and x minus 2 equals plus or minus the square root of 5/2. We're definitely not going to leave that fraction in there. Move the 2 to the other side. 2 plus or minus, I'm going to multiply numerator and denominator by a 2 under that radical. And I get 2 plus or minus the square root of 10 over 2. And that is it for example 13.